Hello students, hopefully you would have enjoyed listening to all the set of lectures on rotational motion. In case you have any doubts, feel free to discuss about it. Now, this being the last part wherein we'll be understanding about the angular momentum and its conservation. If you remember, we had discussed about in the case of linear momentum and its conservation, we need to have no zero external force acting on the object. In a similar manner, when the net torque acting on the object is zero, that results into a conservation of angular momentum. So let's see how it works and how it is parallel to the case of linear momentum.
So let's now try to understand more about this. So what does angular momentum actually stand for? We have already defined the torque. So the angular momentum in this case is going to be defined by L. So L basically represents the angular momentum of the particle. So this is an analog of the linear momentum. So this is analog, the angular momentum is L and the linear momentum is P. P, as we know, is going to be defined as m into v. The angular momentum of a particle is going to be related to the linear momentum of the particle. So like we had defined the torque, we are going to now define the angular momentum. Value of the angular momentum. So here, if we are talking about this particular mass, as you can see, r is the radius out here. Along with the radius, so what we get as a result, here, this is the radius that is acting at an angle phi, and therefore p is the linear value of the momentum. As a result, what will we get? We can say that the net angular momentum value is going to be the cross product of the radial vector times the linear momentum vector. The value of the angular momentum depends on the choice of the origin. So whatever origin that we have, so based on that, the value of the angular momentum is going to depend on it. The units of angular momentum obviously is going to be kilogram meter square per second, because this is kilogram meter per second, that needs to be multiplied with r, that gives us the kilogram meter square per second. Taking this further, if you have to define about the angular momentum of a particular particle, so what has been done here is the following, that is dl by dt. So this is the change in the angular momentum that has been found, that is going to be r cross mv. So if you use the product rule, so this is the first term, you keep the other term constant, then you differentiate the other term, obviously the mass is constant, and so we'll get v from here cross mv plus r cross me. ma is nothing but the force, but this term is going to go to 0 for the simple reason that v cross v is equal to 0, because the same vectors, if you are taking cross product, that the net result is going to be 0. And here you get r cross f. So r cross f is nothing but the torque. So the angular change in angular momentum is equal to the torque. So what can we define? We will say that the rate of change of angular momentum L of a particle is equal to the torque of the net force that is acting on it. If we take it further, we have to sum up for every individual particle. So we discussed the case of angular momentum in the previous slide. That was for every single particle. So if I have to sum it up for all the particles, what we are going to do now is this, that we'll say that L is going to be equals to sigma Li. Sigma Li means for individual masses Mi, there is going to be an angular momentum Li that is going to be associated with it. So Li, if you just substitute, Li is the angular momentum of that particle, so that can be written as mass into r square into omega. But mr square, that is nothing but the moment of inertia. So the total angular momentum is going to be given by the product of the analog of mass, that is I, the analog of velocity, that is omega. So I into omega gives you the angular momentum of the particle. Further, if I say that L is equals to I into omega, so if I say L equals to I into omega, so I is the moment of inertia, omega is the angular velocity that we have, and therefore there is a symmetricity about the z-axis, right? So that, as you can see, the object is moving about the z-axis, so there is a symmetricity about the z-axis of the masses m1 and m2. Going further on this, as we discussed in the case of torque, when the angular momentum value or when the omega value is moving along a clockwise direction, in that case the angular momentum is going to be upwards by this rule, and similarly when the omega is moving in an anti-clockwise direction, the value of L goes down. So therefore The right hand thumb points in the direction of omega. If the rotation axis is axis of symmetry, this is also the direction of L. So this is similar to the case of torque that we had already discussed. Going further, we define the torque as tau. We define the torque as tau, that is equal to dl by dt for any given system of particles. So torques of the internal forces, so the torques of the internal forces add up to 0 because all the internal forces are just going to cancel out, and therefore the resultant torque as a result of it, that is going to be equal to 0, and if these forces act along the line from one particle to another, the sum includes basically the change in the angular momentum of the particle with time. So change in angular momentum, if I have to define for any x-axis, let's say z-axis, it's going to be defined as dlz by dt. L can be written as I into omega, therefore the change dlz can be written as I into omega. Here again we are assuming that the value of L is not changing. It means L changes only with omega, it does not change with the moment of inertia. The moment of inertia remains constant. Why? Because our axis of rotation does not change. Our radius of gyration does not change. That tells us that the value of I does not change. So the total torque can be written as I into alpha z. Taking it further, if I have to define the angular momentum value, so angular momentum L in this case, if you break it up, let's say this is the direction of L, so you break it up into two components. So this is the along the z-axis, or basically along the radial direction, and this is the tangential direction. So both the directions are perpendicular to each other. So what you are going to do, you have to relate it with the perpendicular component, and therefore we get to the net value of the angular momentum. Now, as we discussed beforehand as well, that whenever you do not have any external force acting, in that case there is what is going to be a conservation of momentum taking place. So what will we get? We'll say that the tau z, so tau is nothing but the net torque along the z-axis. So if there is no net external force acting, therefore there is no torque acting. So if the net torque is 0, that means dl by dt is 0. Or I can say L is constant. So if L is constant, that means the angular momentum is conserved. So this is what is the conservation of the angular momentum. Using this, let's say you have the ice skater, if he or she folds his or her hands, in that case his velocity is going to increase. Similarly, if he stretches them, in that case the velocity is going to decrease. That follows a simple relation, I1 omega 1 is equal to I2 omega 2. So that tells us about the conservation of angular momentum. Hope you understood whatever we discussed. Please keep on enjoying. I will come back to you again with next set of. In case you have any doubts in whatever we have discussed, please feel free to ask your doubts. For that, you need to go to www.askIITians.com. In that, you need to click on the discussion board. Once you click on that, you will find an option of Ask Experts. In this, you can select your category out of the categories that we have out here, and then you can post your question. We experts at Ask IITians will get back to you with the answer within 24 to 48 hours.
So students, what did we understand? As I mentioned that when you do not have any external force acting on the object, in that case there is no linear momentum change, that is the linear momentum is conserved. In a similar way, we found that in the absence of any external torque acting on the system, the net angular momentum is going to be conserved, right? So when the angular momentum is conserved, in that case it does not change. So that is what is related to the case of conservation of angular momentum. So that was the summary of my last part. Now, if we have to summarize what all did we learn in the rotational motion, we understood about what exactly does rotational motion stand for, how is the rotational motion related to the linear motion in the concept of the relation of torque and the force. Similarly, using that we define about the angular acceleration, its relation with the case of linear acceleration. Coming further, we understood that how the torque is related to the angular momentum of the object. Similarly, from the concept of angular momentum, we define the moment of inertia of the different objects. We understood how the moment of inertia is an analog of mass and it depends on the radius of gyration. The radius of gyration is found from the center of mass or the center of gravity. Once we know what is the center of mass and the center of gravity, we can also find out when an object is in rotational motion, what all are the forces that are acting, that is the centripetal and the centrifugal forces. Both of these forces exist in different frames of reference. That is a very most important thing. Once we understood about that, we can find out what are the types of energies that exist. When an object is rolling, in that case there is going to be a rotational motion and a linear motion. The linear motion is going to be of center of mass and rotational motion of the whole object. That results into a total motion of the object. And from the total motion of the object, we can find out the total energy of the object. But supposing there is no force acting on the object and there is no torque acting on the object, that results into a conservation of angular momentum. Hope you enjoyed listening to the whole set of lectures. Stay tuned with all other set of lectures, that is on physics, chemistry, maths and biology with askIITians.com.